All right. Hey, everybody, did we draw color Bohr atoms in our notebooks?
Yes.
All right, so if you flip to the color Bohr atoms in your notebooks, you'll notice that energy level 1 just has what color orbital? S. Okay? All right, David Bowie, energy level 2 has how many? What letters? Energy level 2, what letters are present? What letter orbitals are present? Yes, S's and P's. S's and P's. Energy level 3, what letters are present? Class. S's, P's,
D.
and D. And energy level 4, S, P, D, and S. Well, what do those letters represent? What do each know? We don't know? We forgot? Okay,
Yeah,
I'm not surprised we all forgot. They represent orbitals. Okay? They represent orbitals. Okay, class, now go to the Google Classroom and click on the shapes of the orbitals. S's, P's, D's, and F's are orbitals. Everybody tell me in their own words what these things actually are. Nobody can tell me in their own words. Great. Okay.
Say it again, say it again.
Well, these things are fuzzy clouds where electrons live.
Oh, electron cloud.
Okay, they're electron clouds. Thank you, Dean. That's exactly what they are. Okay, if you notice there's only one type of S, one type of P, one type of D, one type of F. How many electrons can you put in each one of these things? Now you can put 2 electrons in each one of these. So 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is what, 9, 10, 2 times 7 is 14. Did we learn that before?
Yes.
Yes, we did. Okay. Did we also, Robs, did we also relate it to this periodic table info right here? Where we had S's and P's and D's?
Yeah, I wrote that
We
down.
did. All right. So, how many groups were the groups with the S's? Which groups have S's?
All of them.
Groups 1 and 2.
Oh,
Well, technically, that's true. Which groups have P's?
group 2.
13 through 16.
Oh, never mind.
Which groups have d orbitals?
Transition metals.
10.
Yes, there's 10 of them. Okay, so you have 3 through 12. The transition metals have d orbitals. And down here, what letter were they?
Yeah.
F's. So S's in groups 1 and 2. Transition metals are d orbitals. These guys over here are P's. Ones on the bottom are F's. Now, those are where the electrons live. We learned about hogs, did we not? We learned about the hog Hilton.
Levels.
Okay, the hog Hilton teaches you how to put hogs in the hotel, how to put electrons inside orbitals. All right. Now, what we're going to learn right now is there are actual names for the rules for hogs. So what I want you guys to do is go to the rules where the hogs are, and we're going to learn the actual names associated with them. Here we go. Go to the rules. Rule 1. Rule 1, Nathan. Yeah. About hogs. Let me get to it. Sorry. Hogs are lazy. Okay? Hogs are lazy. If we go to page, follow and I. If we go to page 156 in our textbooks, I want you to go to page 156, and I want you to see the word that says aufbau principle. Okay? 156. Somebody read me the aufbau principle, please.
States that each electron occupies the lowest energy orbital.
Okay, so lowest energy orbital first. Well, what rule is that? Hogs are lazy. Okay, all right, next, I want you to go to the Hunds rule. Please read Hunds rule. 156.
States that single electron with a transpin must occupy each equal energy orbital before additional electron objects can occupy the same orbital.
Okay, so each electron must occupy each orbital first. So what that means is, if you have 3 separate beds, do you go like this? Is this correct?
Oh, you gotta go up.
That
all
is
around
not
first.
correct. So they gotta go up first. Do hogs like each other, or do hogs hate each other?
Hate each other.
Hogs hate each other. So over here, the pig hotel, hogs can't stand each other. Okay? So hogs can't stand each other. Write that down. Write that down. Take a picture of it first, write it down later, or whatever. Don't just sit there and group chat. The last one is called the Pauli exclusion principle. Okay, Pauli exclusion principle. Professor Dave Pauli, what is the Pauli exclusion principle?
They said maximum two electrons not present in atomic orbital, but only if the electrons had opposite spins.
Okay, so is this correct? Do they go up, up?
No.
How do they go, Nathan? They go up and then they plop. Okay, you have a up and then you have a plop. Pauli, plop. They face in opposite directions. Okay, opposite directions. Okay, people, hogs are lazy. Which rule is that? Which principle? Aufbau. That's German, by the way. It's a German word. I'm not sure exactly what it translates to. I think it means lowest first. Hogs can't stand each other. Whose rule is that? Hunds. Hogs hate hogs. And pigs plop upside down. Electrons plop this way. Pauli exclusion principle. Okay. What would be the point of even learning this crap? Why would we want to learn this? How is it relevant to our lives? Well, I'll tell you. Okay. Do you have your phones?
Yes.
Go to your settings and tell me how many gigs you have on your phones. How much storage space do you have on them?
64 gigs.
64 gigs. How much do you have left? 20 gigs? 9 gigs?
29.
How much you got left?
Yikes.
What if there were a way to increase the amount of storage on your phone by 1 million
How you do that?
without making the phone larger? Making it smaller, in fact. And the answer is, okay, regular phones, regular computers, they use circuit boards to store information. Switches, on-offs. They have little capacitors, they have little circuit boards made by robots, okay? And the switches go on and they go off. Well, what if there were a way that you could store information using up and plop? Well, then you could store millions more times information using electrons instead of on and off switches. Okay? So Hunds rule and Pauli plop are quantum physics. You're learning quantum physics today. Okay? Quantum physics. Has anybody ever heard of a quantum computer? Nobody's heard of that? Man. You know, all you do is you guys watch video game walkthroughs and peanut butter jelly time videos.
What? Peanut butter jelly time?
You don't watch anything educational?
Yes.
There's so much educational stuff on the YouTubes. Quantum computing is the future, guys. Okay? Quantum computing is like a million times faster and better than regular computers. And you do it with electrons. You store information based on whether the pigs are up or plopped. You can store a million more times of information and make it a million times faster. Quantum physics. You guys are learning quantum physics. Okay? Does that make sense? Alrighty? So eventually these phones will become watches, and 100 years from now they'll become just earpieces, maybe not even 100 years from now. 100 years from now they'll probably be implants, Rob. Would that be cool? You have an implant right here. You just display everything right with your eye retinas.
So cool.
Cool.
So it's heading, but it's heading that way because of quantum physics, because of Pauli plops. Is it gonna help you make $1 million on TikTok? No. Is it gonna get you a job at the food line? No.
Maybe.
Okay? Is it gonna get you hired at Browder's Towing? No, it's not. Okay, but is it gonna help the world? Yes. Yes, this is quantum physics, this is the future.
Apparently it gets you on that.
Okay? So, oversimplified, what we're doing is, we are taking electrons and we're putting them in orbitals. The reason why we're having to learn this, Rob, is because somebody told us that we don't know exactly where electrons are.
Heisenberg.
Who said?
Heisenberg.
Heisenberg said we don't know exactly where electrons are. Einstein thought we could. If you knew exactly where electrons were, not only would you not have to learn this, but you could predict the actual future. If you knew where electrons were going to be based on calculations and maths, you could predict tomorrow.
How you do that?
Super complex math. But since you can't, this is the best we know. This is basically what we know about electrons as humans. Not even mentally you do this stuff. You guys have already learned 10 times the amount of stuff that mentally you do. Okay, quantum physics. All right, now, if you guys would, on page 156, you see something that looks like this. It has 1 S's, 2 S's, 2 P's. It's a pig hotel. All right, it's a pig hotel. How much of this did we do yesterday? Did we put pigs in here? We did?
Yeah.
All right, we're gonna use our pig rules to put pigs in here. Here we go. How many pigs did we put in here yesterday? 15 pigs? What did you guys do yesterday?
I think.
Oh, we did?
Yeah.
Yay! All right, did I teach you how to do the superscripts? I didn't.
Yes, you did.
I did?
Yeah.
All right. So if I put if I go like this, if I go up, plop, right, up, plop, then I go up, up, up. Okay? What you write is, in this 1s orbital, you have superscript 2 hogs. 2 hogs. Okay? In this 2s orbital, you have superscript 2 hogs. 2 hogs. In this orbital, 2p, I have 3 hogs. 3 hogs. Do you know, David Bowie, what a superscript is?
Nope.
Okay, David Bowie. You ever done math? You ever taken a math class?
Took a trade.
You ever done that? X squared? That's a superscript because Superman flies high in the air. You ever done this? That's a subscript because submarines go down below the ocean. Okay? Alright, so the superscripts mean the number of electrons in each orbital. Again, why are we learning this? Well, because quantum physics. Okay? Alrighty, so you need to know, you need to be able to do where the electrons are in each orbital. Now, I'm going to share with you, today I'm going to teach you how to put the electrons in the hotel, Rob, without memorizing anything. Okay? Alright, because you want to know how I had to do it? Check this out. Check this out. Turn your books to page 160. Turn to page 160. Look at this with me. Look at this thing right here. It says filling atomic orbitals. Look at that. Look at this little chart right here. Do you see that? You know how to memorize this in high school? You know whose chemistry teacher made him try to memorize this in high school? Take a guess.
Yours.
Me. Okay, me, David. Do you want me to make you memorize that for a test next Wednesday?
Please.
You wouldn't like that. You failed it.
Yeah.
Did I fail it in high school?
No.
Yes, I did. I failed it.
That's crazy.
Not you, you didn't fail.
Oh, I failed.
Oh, God.
Total F.
That must have been hard.
Yes, because nobody, we didn't, know what this was or why we had to memorize it. We were like, this doesn't make any sense. S's, P's, F's, what's this crap? I am not going to do that to you. Okay?
We appreciate
You
it.
understand that? So Ms. Hicks, is what we are going to do. We're going to learn how to do this correctly with no memorization. Okay? Robs, you should be happy about that. No memorization at all. So that means if you have a free day and you just don't study, that means you still should be able to do it on the test. Okay? All right, now go to page 156. Do you see the pig hotel? That's the full pig hotel. That's all of it. I'm going to teach you how to fill this thing and go in order without memorizing anything. Okay? That makes sense. Any questions so far? All right, so here we go. What you need for this exercise is you need your, Rob, you need your periodic table with all these, this stuff, the info, right here. You got that? All right, have that in front of your face. Okay, open up to page 158. 158. 158. What we're going to do is we're going to write a big hotel and all the electrons and all the orbitals, we're gonna write it sideways for any atom on the whole periodic table without memorizing anything. Without memorizing anything. Okay, Chanel? How does that make you happy that you don't have to memorize anything?
You want this?
Good. Because let me tell you, alternative sucks. Okay, all right, here we go. Everybody, we are gonna write the electron configuration, in other words, the pig motel, for hydrogen. Here's how it goes. Hydrogen is in row 1 in the periodic table, isn't it? Put a 1. Okay? And in that element right here, what letter of orbitals does it have? S. So it has an S. Well, how many total electrons does hydrogen have? 1. Superscript 1. And then I'm going to draw it. There's a pig. There's a pig. Okay? Look at that. Are you ready? Helium. 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 Charles Christopher, where is helium in row 1 of the periodic table? Remember,
No.
rows go this way, they go this way,
No.
they go across.
It's an 8.
Does helium in the first row of the periodic table?
No.
Yes.
Yes, no, I don't know.
Helium. Helium. Row number 1. Row number 1. Row number 2. Row number 3. Row number 4. Row number 5. Row number 6. Row number 7. Just like 7 energy levels in fluoride. Okay? So yes, helium is in row 1 in the periodic table. Okay? How many total electrons does it have? 2. It has 2 total electrons, and they sit in an s orbital. So you write an s2. We're going to draw them. They go up and plop. Okay? Take that back, Rob. You need to know where the s's, the p's, and the d's are. Do you think you can memorize that? Where the s's, the p's, and the d's are? No?
Yeah.
And why are they the names that they're like S and D's and B's?
Okay.
Yeah.
The reason is because those elements have those orbitals.
Yeah, but like why are they the letters?
Why are they the letters?
Yeah.
Why did I put P1, P2, P3,
Yeah,
P4?
but why do they pick P of all
Why did they pick P? I do not know. I would have to ask Schrodinger why he put a cat in a box.
To make
But
it go alive, yeah.
I like it.
They picked P for the same reason they put a cat in a box. Okay, now move on to lithium. Dean, look at the periodic table. How many electrons total, period, does lithium have total?
Lithium?
Yes.
It's not on there, Bobby.
Alright, so it's the third element in the periodic table. Right, Ms. Hicks? And does it have 3 electrons?
Yes.
Yes, it does. Well, here's what it also has, okay? It also has the same amount of electrons as helium does, so you're gonna write 1s2. And it has one more. It's in row 2, where the s orbital is, it's got a little electron there. Check this out, check this out. Superscripts, okay? Charles Chris, look, what is superscript 1 plus superscript 2? That's a total of 3 electrons. Up, plop, up. Oh, look, 3 little pigs. We're putting the pigs in their orbitals. Why do we want to put the pigs in their orbitals? Well, because if you know where the pigs are in the orbitals, you can do quantum physics. Why quantum physics? Well, so that you guys can make TikTok videos. Okay, that's it. Okay, because physicists went to school and they learned how to do this. You all now get to do peanut butter jelly time on the TikToks. Okay? And you're learning this so that you guys can go create holograms for your kids so they can go peanut butter jelly time.
Oh my god.
All right, lithium, beryllium. How many electrons does beryllium have? Nathan, sleep man, how many electrons does beryllium have?
Beryllium
Yes,
is
sir.
4.
4. All right. 1s2, 2s,
1.
2. Oh, looky here. Superscript 2 and superscript 2 make 4. 4 electrons. Up, plop, up, plop. You see them, Dean? You see 4 electrons? 4 pigs? Do the superscripts tell you how many P's are in each letter? They do. Do these numbers in front tell you basically what row the element is in? Yes. Okay? But look, I can't just write this miscase. Okay? Look, Taylor, not Summer. I know. If I just wrote that, then how many pigs did I draw? Well, does beryllium have 2 pigs or 4? I have to include all of them.
Oh, gotcha.
I have to write all of them. I can't just write 2 of them. You understand that, Whitney, or not? Shrug shoulders? Okay, so almost. Nathan, you sleep?
No, I don't sleep.
You watch this on Netflix. Boron. 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 All right, you're going to rewrite this. It's got the same number of electrons here, plus 1 more. Now, what letter is over here, though, guys? Are these the S's or are these the P's?
P.
We're in the P section now, Robs. We're in the P section. So we're going to write 2P. 2P. 1. Well, Dean, does boron have 5 electrons?
Yes.
Is subscript 2, superscript 2 and superscript 2 and superscript 1, is that a total of 5?
Yes.
Yes, it is. Okay. Every time you have an S, how many spaces do you write? How many beds? How many beds are there for an S?
At least
1. How many beds are there for a P?
2, 1, 5, 3, 4.
How many P shapes were there? How many P shapes were there? Look at your shells, look at your orbitals, look at the little shape thingies.
5.
How many different shapes did P have?
3.
3. So you write 3 empty beds. And you put a pig in it. Okay?
Sorry.
Up, 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 pig. There you go, 5 pigs, 5 electrons.
Slowly.
Okay? You gotta remember, the S's had 1, the B's had 3, the D's had 5, and the F's had 7. Alrighty? What in the heck are we learning, Cody? Are we learning how to put electrons into orbitals? Okay, are we learning how to put pigs in hotel rooms?
I guess.
We are. By learning how to put pigs in hotel rooms, are we learning how to put electrons in orbitals?
Yes.
We are. Is this gonna help you get a job at
Yes.
Safeway? No, not at all. Just gonna make you run faster. Is it worth learning because quantum physics? Yes, it is. Alright, carbon. Robs, how many electrons does carbon have?
6.
6 total. Alright, so what do you think's gonna happen here? We're gonna keep everything the same and then add 1 more thing?
Yeah.
We are. But everything you go over again. 2s2, 1s2, 2s2, 2p, what?
2.
2p2. Okay, 2p2.
Hold on, why is it 2 now?
Well, remember now, the superscripts tell you
How many?
the electrons. Now, what is 2 plus 2 plus 2? 6.
6 electrons.
Okay, every time we have an S, how many beds do the pigs get? 1 bed. Miss Hicks, every time we write an S, how many pigs do the bed? How many beds? 1. Dr. Charles Mann, every time we write a P, how many beds? 3. The shapes, guys, the shapes. 1, 3, 5, 7. Okay, Anaya. Up.
Pop.
Plop. Up. Plop.
Up.
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 Up. Repeat it, Hans rule. What? They don't go up, up?
No.
They do go up, up.
Like,
What's the rule? Hogs hate hogs, don't they?
That's the first.
Whitney, nitrogen. Can you go faster? Can anybody go faster?
Maybe.
What's that here? That's 7 electrons? Okay, can you guys write the pig hotel for me, please? Can you tell me what to write?
Okay.
Anybody?
1s2, 2s2,
2s2,
2p2, and
2p.
1. Oh, 3. Wait, I thought it said 2. Oh. How?
That's 7.
2 plus 2 is 4.
Plus 3 is
4
7.
plus 3 is
Yeah, but
7.
okay.
7 total electrons. Oh, every time I have an S, 1 space. S, 1 space. P, 3 spaces. Up, flop, up, up. Quantum physics, guys. Quantum physics. You mean backwards? Oh, lower down the periodic table?
like potassium.
Oh, yes. We're not ready for that. Here we go. Tell me the next one. Hello? Anybody? Barbara? Chanel? 1s2? 2s2? 2p. 2p4. Well, why is that, me? Plus 2 plus 2?
4 plus 4 equals 8.
4?
8 electrons.
Yes. S, 1 bed. S, 1 bed. P, 3 beds. Up, plop. Up, plop. Up, plop.
Why was the last one plop?
Well, I plopped right here, Rob. Okay? The last one wouldn't be plopped because what is the rule? Hunds hate hogs and Pauli's plop rule. So you're going to fill this one first. Fluorine. Tell me. Ready, go.
1 S2,
1 S2,
2 S2,
2 S2,
2 P5.
2 P5. What is 2 plus 2 plus 5?
9 electrons.
9 electrons.
Nice.
That's right. That's right, Nathan. S gets a bed. S gets a bed. P gets 3 beds. How's it go? Up, plop. Then what?
Up, plop,
Up, plop. Then what?
up,
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 plop,
plop,
plop.
plop. Yeah, it has to be. And then the last element, neon. Okay? Neon. Somebody do it.
1s2,
1s2,
2s2,
2s2,
2p6.
2p6. P, what's 2 plus 2 plus 6?
Thank you, darling.
That would be
10.
10
All right, S gets 1 bed.
For every S is 1.
S gets 1
P
bed.
is 3.
P gets 3 beds. All the time, Robs. What's this? Up what? Plop. Up, plop. Up, up, plop, plop, plop. Well, looky there, it's a noble gas, Charles Christopher. There's nowhere else to put any more pigs. So, you ever notice that the ones with the empty spaces can make like charges? You ever notice that? You ever notice the ones that have room to accept more pigs are the ones that can do ions? Yeah, they are. Okay, look at this. Hydrogen's got room for a pig. Guess what? It's explosive. Lithium has room for a pig. Guess what? It's explosive. Boron. Yep. Boron's a little explosive. Carbon's very reactive, believe it or not. That's why everything's made out of carbon. Nitrogen, believe it or not. You ever heard of nitrous? Where the cars go vroom, 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 zoom, zoom, zoom? Okay, well that's because it has nitrogen and oxygen. Those are very reactive. Oxygen makes things boom. Why? Well, because it has space for electrons. Fluorine is super reactive. It's got 1 extra space. And then what happens to neon? Nothing. Helium, nothing. No extra space for electrons. All right. Hashtag
Boom.
PHS chemistry.
No. Hashtag boom.
Like, subscribe, comment,
Share.
share, smash the bell. Smash the bell, please comment.